So I'm going to skip all the linear. Yeah. Yeah. Okay, let's try this.
All right. So 2x plus 1 equals 9. And what is that? Just to find x then?
Yeah.
Okay. Take away 1.
Yeah.
And then divide by 2, so x equals 4.
And they told us that y equals 1. That's fine. How about this?
Divide by y. The first one. So you get x divided by y equals 2.
And then?
And then I'm not really sure actually.
X is 2y.
Yeah.
So how could you?
Yeah, I know. So substitute 2y for the x. So 2y plus 3y equals 15, which is just 5y. And then divide by 5, y equals 3.
Is that full marks? Simultaneous?
And then find x, yeah. So x equals 2 times 3, which is 6.
Well done.
So sub in x, so 2 bracket, or 2 times 3y, which is just 6y plus y equals 28. And that is 7y. So you divide by 7 to get y equals 4. And then you do 4 times 3 is 12, so x equals 12.
This one.
Sub in, so 2 bracket 2y minus 1 plus 3y equals 12, and then you expand and simplify, so 4y minus 2 plus 3y equals 12. So you have 7y minus 2, and you can plus 2 to both sides, so you have 7y equals 14 divided by 7, y equals 2, and then you sub in y into the first equation, so you get 2 times 2 is 4 minus 1 is 3.
Well done. How about this?
So you sub in minus 3 into the y, so it's just x squared plus 9 is equal to 10. Then you take away 9 from both sides. So you get x squared is equal to 1. Then you square root, and the square root of 1 is just 1. No, it'd just be root of 1.
What is the square root of 1?
1.
Yep. And they told us y equals minus 3. Is that it?
Yes.
Is there another very similar number that when you square it you also get 1?
Minus 1.
Yes, x equals 1 or x equals minus 1. And
right.
they told us y equals minus 3. Let's Just watch for that. So we're now getting into quadratics. 2 answers is not uncommon. Okay, how do we do this?
Sub in y, so you have x squared plus bracket x minus 7 bracket x minus 7 equals 25. Then you expand, so x squared plus x squared minus 7x minus 7x plus 49. And then you collect that term, so 2x squared minus 14x plus 49 equals 25. So you could just take away 49 from both sides. So 25, that is minus 24 equals minus 24.
Okay.
And then you can factorize this.
How would you do that?
So 2x bracket x minus 7.
What type of equation do we have?
Quadratic, so add 24 to both sides.
Yes.
So something to let's make 24, let's make 14. That would be 6. Oh. 12 and 2.
A whole lot of no. I notice that they're all even numbers.
By 2.
Yeah.
So you get x squared minus 7x plus 12.
Yeah.
And then we've got 3 and 4. So minus 3 minus 4, x minus 3, x minus 4. So x equals 3 or x equals 4. And then y equals, for that one, 3 take away 7, which is minus 4. Or minus 3.
If these were 2 graphs, what would be the coordinates of where they cross over?
Would it be the solutions?
Yeah. So coordinates.
So 3 minus 4.
Yeah.
4 minus 3.
Yeah. Sometimes they ask for the coordinates, and so you give them a coordinate. This time they didn't, and I think it's mostly just fine.
Yeah, I remember. One of these was the entrance exam, and I forgot to do simultaneous for it, so I didn't get that one.
You got enough. You got enough. That's the main thing.
Yeah.
Let's see. So they go up to 5 marks, 6 marks, but it's the same idea. How do we do this one?
You would try and make x or y the subject, so you could take away y.
What would you get?
X equals 2 minus y.
What would you do next?
Then you would sub it into the first formula, so you get 2 minus y plus y squared equals 9.
Oh, sorry, because it was x, wasn't it? Yeah. And then you'd go from there, and you're gonna be fine for the rest of that. Sorry, it was x equals, so 2 minus y. 2 minus y plus y squared equals 9. Yeah, so if it's not the subject, make it the subject.
Yeah.
That was alright. How do we solve this?
Take away 4 and add x to make it equal 0.
And that's all I needed to hear. How do we solve this?
Would you make one of them not equal y? So maybe for the second one, take away 2x from both sides. So you have y minus 2x equals 8, and then you can sub in.
How would you sub that in?
You sub in y, so you'd do x 2 times x squared plus x minus 4. Minus 4, sorry.
Say that again, sorry. 2x squared plus, is that it?
2x squared plus 2x minus 8.
Nope. That would be if it was y squared plus y. Ours is that's who you're thinking of.
Would you make x the subject for the right equation?
What would you get?
Y minus 8 divided by 2.
And then?
You sub that in.
What
So
would
you get y minus 8 over 2 brackets y minus 8 over 2. So you just get
Hold on, keep going.
plus y minus 8 over 2.
Keep going.
Yeah, it is. Minus 4.
Okay. So real tricky stuff.
You just times the fractions.
Hold on. So yeah, bunch of tricky stuff. That would be if you made x the subject and subbed it in.
Yeah.
Okay. Y is already the subject. Y is already the subject.
Oh, okay. You could just make it so that 2x plus 8 equals x squared plus x minus 4. Right.
Please God, do it that way. How would you go about solving this?
Make it equal 0. So minus 2x and minus 8.
Yeah. And you would solve it from there.
Yeah.
Nothing is going to give you any difficulty there. Solve that, get your 2 x's, and then you get your 2 y's. Okay, let's do this one.
The intersect. Right. Sub y in. So x plus 2 equals x squared plus 2x minus 4. Minus x plus 2. So you get x squared plus x minus 2.
Not minus 2.
minus 6. So 3 and 2. So 3 minus 2. So x plus 3. X minus 2. X equals minus 3 or 2. And then you sub into the y equation to get, for the first one, y equals minus 1. The second one is y equals 4.
Coordinates?
Minus 3, minus 1, and 2, 4.
And that's what it looks like. 2, 4, minus 3, minus 1. That's a curve, that's a line. And so to find out where they cross over, solve them simultaneously. Quite common for equations to be written y equals. And so it's, if you have to do that, just equate them to each other. Any questions for that one?
No.
What hints does this give you? Give your answer to 2 decimal places.
Use the quadratic formula.
Yeah, it won't factorize. There won't be factors like 2 or minus 3 there. Yep. And so you'd use the formula. Okay. I taught you well. Okay, solve simultaneous equations. So what should you give yourself there? Quadratic simultaneous?
Good.
Okay. Very good. And you're also good for quadratics. So let me close that. Let's see. So we just did solve simultaneous equations up to 6 markers. Let's assume you're good for linear. Good for quadratic. We did solving algebraic fractions, didn't we?
Yeah, I think we did.
Yeah, we definitely did. I bet we did solving inequalities as well. Non-linear sequences, you're gonna be fine. Did we ever do vectors? Yeah, we did the first half of it.
Yeah, we did. And I said we did the easy part, and then there's like a hard part.
Yeah. Do you know the hard part of vectors, or you're not sure about
it? What's the hard part?
Like proving that 2 vectors are parallel and that type of stuff.
No.
Okay. Yeah, let's do that.
All right.
Vectors.
Finish? Mm-hmm.
There we go. And let me just see if I have your exact one actually. Vectors, I do. Wow, we really did scatter diagrams, did we?
Yeah, we did.
I didn't tick a single thing on that list. I really didn't. You take that off. Okay, vectors. Let me see this. We didn't do bad. Okay, let's try this one. So the answer to part A is there. Try.
Right.
Hang on. No. That's just more the same. Let's do this one.
This one? Right. So it'd be 5/7
Yeah.
LX.
Yeah.
B would be 2/7
Yeah.
X. And then 7/7.
So this one here, make LX the subject.
You would divide by that. No, you take it away.
Which one?
Um, would it just be 5/7?
That's this one up here. Make LX the subject.
7/2.
Yes.
Yes.
So strangely enough, lots of this vector stuff that you were doing before, this is 1/3 of the line, this is 2/5 of the line. You're now going to get something where it's 7/2 of a line, so it's bigger than the line. Okay, let's try this one.
Let me see. Is it supposed to say O to M instead of O to N?
No. What that tells you is that, make this a bit bigger. What that tells you is that N is somewhere out here. No lie.
Right. So you would find O to M, and then that would only be 3/5 of it, and then you just times it by 2/5.
Let's find O to M first.
O to M is okay.
No. Hold on. Okay, so O to M is 3/5 of O to N.
Yeah.
So what is O to N?
Is 5/3.
Yeah, 5/3 of O to M. Okay.
Yeah.
Okay, now we'll do it.
Right. Well, you first find A to B.
Mm-hmm.
So B minus A. And then O to M equals A plus half B minus half A.
Mm-hmm.
And then collect it all together, so OM equals half B plus half A.
Yeah.
And then ON equals 5/3 times half N, half A, sorry, and plus half B. which is 5 over 6a plus 5 over 6b.
Well done. 3/4. Did I do the wrong question? That's the wrong answer. Hang on. No, OM. M is the midpoint of AB. So we want O to M. So O to M is A plus a half AB. So it's going to be A. So that's correct.
I think we put the 3 and 2 the wrong way.
Oh,
Maybe.
O to N. Sorry, that's why. Sorry, the whole thing. The whole thing is 3. And this is 2. So that's 2 and that's 1, is it? The whole thing is 3. Yeah. Because I'm still just so used to the old normal way. Okay. And so what should it be then?
It should be so O to M is equal to 2 over 3
Yeah.
ON. And O to N equals 3 over 2.
Yeah. So that's 3 over 2.
So you have 3/4 and then 3/4.
Yeah. There you go. 3/4. That's it. So yes. So the whole thing was O to N. Okay. Things are about to get weird. Okay. Let's try this one.
Doing this one?
Yeah.
Minus 2a minus b plus 4a plus 3b.
Okay.
So it's just 2a plus 2b.
So x to y is 2a plus 2b. Okay.
Would you put 2? Wait, hold on.
So that's
2, then 1 is for, yeah.
So I think that's it.
So we need to do times x to y times it by 2.
Say that again, sorry.
Oh wait. That would be 5 over 3.
What is 5 over 3?
5 over 3 is x to z.
It has to be 5 over 3 of what?
Of x to y.
So let's compare x to y to x to z.
Yeah.
So what fraction of x to z is x to y?
3/5.
Isn't that y to z?
That is x to y.
Sorry about that.
That's right.
I'll try this.
I'm not sure.
X to y is 2/5 of x to z.
Yeah.
And so x to z is? What fraction of x to y?
5/2.
Yep. Okay, let's do it.
5/2 2a. So you get 5/2 bracket 2a plus 2b.
Mm-hmm.
So you get 10/2a.
Yep. What is 10 divided by 2?
5.
Mm-hmm.
So you get 5a, 5b.
So this one here is what, x to z?
That is, yeah, x to z.
What do they ask us to find?
O to z.
What else we need to do?
We need to just take away, add 2a plus b.
Yes, well done. And so what do we get?
7a plus 6b.
7a plus 6b. Well done. Yes, x to y. So for part A, we found x to y. So good idea is we might have to use it. X to y is 2/5 of x to z, and so x to z is 5/2 of x to y. Any questions about anything there?
No.
Okay. Let's try it. Hang on, let me just see something. That was 2a plus minus 4a, sure. I'll say, yeah, let's do this.
I'll just see. So a to b is 2, b to c is 5. Put that down now. So a to b is 2 out of 7.
Mm-hmm.
So
2/7 of what?
2/7 of 8. Wait, of a to b. Wait, of a to c.
Yeah.
And then a to c equals 7/2a, baby.
Yeah.
Yeah. Alright. And then a to b equals minus 2a minus b.
Yeah.
Add 3a, add 2b.
Yeah, what do you get?
You get a plus b.
Yeah.
So you should get 7 over 2a plus 7 over b, yeah. And then you just add 2a plus b.
Well done.
And that is just... It'll be 11 over 2a plus 11 over 2b.
We were adding 1b.
Oh, 1b, sorry. So 9 over 2b.
Over 2b. 11 over 2a. 9 over 2b. There we go. 4 marks. Any questions there?
No.
No, and you nailed it. Well, that was 4 marks, not 3. What you give yourself there?
Alright.
I'm going to say tick. Okay, find 3 parallel vectors.
C to D and A.
Yeah, C, D, and A. How about the one down below?
The second one in, both of them.
Yeah. Wait, yeah.
It's kind of just like ratio, isn't it?
Yeah. So the way it's if they factorize. So this one here has a common factor of -4, p minus q, and that has like p minus q. Anything else?
No. Wait, no. 3. Oh, there's 3 pairs, right? 6q. The second on the left. Those 2.
These 2?
No, from the right. Yeah, those.
Yeah, so that's you can factorize out -3 and you get p minus q, and the other one you factorize out 2 and you get p minus q. Sorry. Oh, those aren't. No, not at all. You can't factorize out anything for the top one, can you?
No, you can't.
No. So another one underneath it is p minus 3q.
Wow, this is really confusing.
Yeah, it's pretty confusing. Well, these 2 are definitely parallel. 2p and 5p.
Yeah. And
then the other ones is because you're factorizing out a minus, is it? Let's not get confused. Okay, how about this? So this is kind of more like it. Okay, which are the parallel vectors?
CD and GH. No, my bad. But not no. A, B, and EF.
A, B, and E, F. Yeah. Allegedly, there's one more.
EF and IJ.
Sorry?
EF and IJ.
Well, what does EF factorize to be?
Oh,
sorry, we did that one. The IJ?
4.
And
yeah, 4, 3A minus 2.
So that's not it.
Right. Okay. That's right.
Hi, can you hear me?
Hello?
Hi, can you hear me all right?
Yeah, I can hear you now.
Okay, right. I think we're good enough with the whole parallel idea. Let's go with this one.
Oh, what was it? GH?
I don't know. You just fully factorize all of them.
Okay.
GH, yeah, it's probably GH. What is it? 2A minus B. Yeah, factorize out minus 1. And you get 2A minus B.
All right.
Yeah.
So when you get a question like that, just factorize them all and then see which ones have the...
Yeah, when we factorize the minus 1, there's no need for a question like that. Okay, this one.
Show that, wait, what? A, B... right, so... Would you first have to find AB, and that would be minus 2m plus 2n.
Okay.
And then you have to find n to n, which is just minus m plus n.
Mm-hmm.
And then you can factorize the first one to make it minus 2 bracket minus m plus n.
Yeah, and so
and because they're the same, they're parallel.
So you just need to say something like AB is twice mn, therefore parallel.
Okay.
Some of that. So that's fine. Fine. And then the last one was AB is equal to 2mn, or AB is a multiple of mn, something like that.
Right.
Okay, this one.
Oh, A, B, C. Wait, where's M and N?
I think I must have done the wrong one, did I? I think it's just the same as the previous one, did I? What were we supposed to show are parallel? All right, let's pick two lines and show that they're parallel.
Okay.
M. No. Sorry, M is the midpoint of O to E.
O to E. So there. Yeah.
So that's.
Are we supposed to label them ourselves?
Yeah, I'll have to, but I mean, this is how it is. I think it helps to just put it on. And that's N. Yeah, and they don't always do it for you, so. Okay, find the vector M to N.
Huh. Well. You would first have to find what O to E would be.
Yeah.
And you could find that by doing no, wait. It's quite tricky, yeah.
So O to E is gonna be the same as, let's say,
A to the midpoint or
A to the
B.
midpoint. Yeah.
Yeah.
So how would you get from A to the midpoint? And I suppose maybe this will help. Just these are all B, aren't they?
Yeah, those would be.
And A.
Oh, right, yeah. Okay, yeah, no, that makes sense now. So A to the midpoint would be minus A plus B. So B minus A.
So from A to the midpoint is B minus A. Yeah. And so O to E.
O to E equals B minus A.
Okay.
And there'll be half of that, so it'll be half B minus half A.
So M to E is half of that.
And then N is just A to N would just be half of A to B, which is just half B.
Mm-hmm. And so M to N.
N to N would be them added together.
Yep.
So B minus half A.
Yeah. And then part B.
It's quite pretty. That shows that OA is parallel to MN.
Don't think it does. It's supposed to, though. Why does it show that it's parallel? O to A is just A, isn't it?
Yeah.
So that's just A. Were we supposed to end up with a half B minus a half B and end up with just a multiple of A? What's happened here? So from M to N. So we had to go. I think did we go in the wrong direction? We went from A to the midpoint, but we should have gone. No. So we're going from O to M. So we go there and then there. Oh, sorry, no. We just found M to N. And now they're asking about, they're asking about M to N, aren't they?
Yeah.
Did we find M to N? So M to E. Hang on, brute force time. So M to E. So it's from here to, it's half of O to E. That's the same as that. So here we go plus B minus A. So it's a half B minus a half A. Yes. So M to E is a half B minus a half A. Then we add A. Then we add A. So do you see that way? A half A plus A and then minus a half B.
Yeah.
So M to E plus E to B plus B to N. So that was a half B minus a half A, then plus A, and then minus a half B. What do we end up with there?
We end up with no B's, and you just get 3. No, wait, that's 2. 4 over 2, which is just 2A.
You have A plus A minus a half A.
So 3 over 2, so 5 over 2. A.
So it's 2 minus a half, not 2 plus a half.
2 minus a half is plus a half.
2 take away 0.5.
1.5. So 3 over 2.
Yeah, 3 over 2 A. And so what does that tell you about those two?
That it is parallel because it can be factorized just to make A. What's a multiple of A?
Correct. So what's the formal way of saying it?
M to N is a multiple of O to A.
Yeah.
Therefore parallel.
Well done. Multiple of O to A, therefore parallel. And M to N is 3/2 of O to A. M to N is parallel to O to A for that or follow through. So this time they wanted the 3/2 thing. Mn is 3/2 of O to A. Okay. So I don't know. We went wrong with a minus. We did a half plus a half. We should have done a half minus a half. Something went wrong in there. Any questions about anything there?
Not really.
So my way of doing it is just kind of just brute force. Like this here is a half B plus a half A, and then that's plus A, that's plus A, and that's minus a half B. So there's nothing fancy. Just find the root from one to the other.
Yeah.
3 mark parallel.
That was a 3 marker.
Yep. Well, there's 2 halves, so in total it was 5 marks.
Okay. Yeah.
Parallel, basically. Parallel vectors. That one. I just want to see. So there's a bit of parallel stuff. Okay, so we got most of parallel done, and there's one thing at the end that's called collinear, and it's to show that they're on the same straight line. So you show that they're not only are they parallel, but they share a same point. So if two, you'll see this word collinear.
Yeah.
That means on the same straight line. To show that they're collinear, show that they're parallel, and then show that they share a point. And that's an easy thing, because one is, let's say, O to M, and the other is M to N, and obviously the shared point is M.
Okay then.
And that shows that they're on the same straight line. Yeah, how was that for you, Oliver?
That was alright. Quite hard.
Yeah, that's why I picked it. It's as hard as it gets. Anything in particular you want to do next time?
No, you can choose again.
Okay, I don't think there's anything harder than that. But anyway, see. Any questions for me in general?
No, that's all.